Hi, my name is Jeremy Rosen. I'm a former college tennis player. I've also coached tennis, and I do sports economics research for tennis and football. I'm starting Topspin shot research to bring new techniques to tennis analytics that dig deep into match data, deeper than just statistics like serve percentages and win probabilities. Because I don't just want to know what the statistics say, but why they say the things they do. To accomplish that, I chart matches and I analyze them. And for some of the professional matches I chart, I write a series of articles, each series on a different topic about tennis analytics. Then for each article, I film a video that summarizes the article, but also adds new insights. So the topic of this first video and the rest of this first series is causal inference, or determining what causes relationships in tennis data. There are two classes of problems in tennis analytics. The first is prediction, and the second is causation. Prediction doesn't care why the data are the way they are, only that you can use the data to make accurate predictions. For example, let's say I'm trying to train a computer program to return serves. One of the things the program has to do is predict whether a kick serve is coming. Say the server, who's the computer's opponent, bounces the ball 1, 2, 3, 4, 5 times before every first serve, but only 1, 2, 3 times before every second serve. Because a second serve is often a kick serve, if the server bounces the ball 3 times, the computer can predict that the serve will most likely be a kick serve. But bouncing the ball 3 times doesn't cause the server to hit a kick serve. The serve being a second serve causes the server to bounce the ball 3 times and hit a kick serve. On the other hand, to give strategic advice, you don't really need to make predictions. What you need to do is understand the causal relationships in your data. Because once you give strategic advice, whatever the old strategy was will change, which in turn will change those relationships in the data. And if you don't understand your data, you won't be able to account for those changes, which can mess up the advice you give. However, this issue doesn't matter for making predictions, because your predictions, like predicting who will win a match if you want to place a bet on it, won't affect what the players do. There are multiple ways to do causal inference. The one I use in this series is control variables. In a scientific experiment, you control for every possible variable, that is, you keep it constant, except for the one you care about. Unfortunately, a tennis match isn't a controlled environment, but with a statistical technique called multiple regression, you can add control variables to your analysis. Some examples of control variables are who's the server, who's the returner, which matches it, along with characteristics of the incoming ball, like how fast it is, whether it was hit with topspin or backspin, or where it was placed. So if this is me, and I'm a righty, whether the ball was placed to my forehand, or to my backhand, or whether it was placed short or deep, that sort of thing. When charting a match, I chart these variables for every shot. It takes a lot of time, but it's essential because if I give strategic advice based on relationships in the data without taking control variables into account, I can end up giving the wrong advice. In this series, I show how that can happen by analyzing the 2016 Wimbledon men's final between Andy Murray and Milos Raonic.